So half angle formula. Again, this class gets how to calculate. In practice, these two play the role. So half angle with something in half of something. Most common method is to do this. Naturally. Sine theta, half of sine theta, half angle. Life's not that easy. Incorrect. So don't make that mistake. You can't write sine theta equals half of sine theta. Easier way to remember. Sine theta, if that were to be true, if you start simplifying, those two would go away. You will end up getting 1 equals 1/2. Yes, 1 equals 1/2 in this word. No. So, don't do it. I reserve these for a reason. So the last part reducing formula, what's this? If I use theta equals alpha over 2, over here I'll have 1 plus cosine 2 times alpha over 2 divided by 2. Cosine squares alpha over 2. Agreed. I simply replace theta by alpha over 2. Over there. This will be gone. One plus cosine alpha. Entire thing divided by 2. Is cosine squared alpha over 2. Now we want to solve for this, so you take the square root on both sides. So cosine alpha over 2 will be the square root of 1 plus cosine alpha over 2. Good. I simply took the square root on both sides. Square root of that entire term on the left hand side. Square root of cosine squared, which simply is yes. Square goes away, the root appears, and then it is removed. Now you see why we call it half angle. We started with alpha, now it is alpha divided by 2 half 49. Of course, one would like to put plus or minus, but keep in mind, even though we took the square root, the plus or minus here doesn't refer to 2 possible values because of the square root. Rather, the plus or minus here refers to so we know sine, cosine keep changing values positive to negative. So we put that plus or minus to indicate whether you're going to have a positive value or a negative value. It does not correspond to the square root. In algebra, when we say, well, square root of 4 is plus or minus 2, because 2 squared is 4, minus 2 squared is 4. But this plus or minus doesn't correspond to the square root, rather it is indicative of the value corresponding to 4. Good. Same logic. You can tell me if instead of cosine alpha over 2, suppose I want to write sine alpha. Any thoughts? I'll give you an answer right here. Okay, so if I go from cosine to sine last time, the only thing that changed was the sine. From plus, it became minus. Naturally, going from cosine to sine, it has to change. Inside the root, still would have plus and minus. Once again, that is what corresponds to that. Yes. So all I did is use this formula instead of the previous one. Plugged in beta equals alpha over 2. Ended up getting that. But I didn't even get into all that solving part because I knew from the previous topic that I go from cosine squared theta to sine squared theta. The only thing that changed was the sign in the middle, plus became minus. That's what I did. But naturally, that leaves us with one other important trigonometric function, and what is that? Tangent. The answer is right here. You can solve it. Tangent alpha over 2. So Nolan gave me the answer, square root of
1 minus cosine A over the square root of 1 plus cosine
A alpha, same thing, alpha here. So Nolan's logic, tangent alpha over 2, sine over cosine. Took the divided that by that to get that. Yes, one way of looking at it. Another way, come back here. Theta is alpha over 2. Yes. Alpha over 2. Alpha over 2. 2, you get cancelled. 2, you get cancelled. So cosine alpha is right there. Cosine alpha right there. But that's equals to tangent squared alpha 2. Take the square root on both sides. You get square root of whatever answer that you had on the right hand side. Agreed? Okay. Doesn't matter which approach you take, as long as you understand. Common mistake, getting rid of that plus or minus. Right? So you look at that plus or minus, you look at that plus or minus, and you say, oh, let me get rid of it and simply put square root of 1 minus cosine alpha is pi by 1 plus cosine alpha. You can't do that because then you are suggesting or implying that sine and cosine go hand in hand at all times. In other words, sine is positive, cosine is positive, sine is negative, cosine is negative. But is that the truth then? Do they always go hand in hand? No. So one can be positive and the other negative. So don't forget the sequence.